Okay, let's just see how this goes so far. Is anyone here? Is anyone here? Anyone? Nope, not right now at least. So let's go to this. So I'm gonna close out all of those. All right. All right. Right, let's see here if I can minimize this and this. Okay, what else do I need to do? Let's see here. Safari. No, yeah, Safari. No. There we go. And now we go to Matthias. Let's see here. Okay, let's see here if I can. Well, time to get the paper. Boom. Wow. This can pick up sound really well. But it isolates the other sounds pretty well, so that's good. Oh, wait. Message. Nope. Nope. Okay, let's get a feel for this. get a feel for this. Let's see here. We need some buckets. Let's insert feel. All of this will work. This is a good practice. Okay. Oh, okay. That's not looking too bad right there. Okay, so let's see here. Oh, I'm gonna show you these. Yep.
Hey.
Hey.
What's up?
Nothing much.
Hey. Okay. Finally, I tried to join on my phone, but new phones are weird and permissions are weird. I couldn't get it to work. Yeah. Oh, how are you?
I'm doing well. Can you see me?
Yeah. Do you want me to turn on my camera?
Sure. Whatever's more convenient.
That works? Yeah. I don't know if it's working or not. Oh wait, no.
Yeah.
Maybe.
Possibly.
I don't know.
It's no big deal. Okay.
Oh, okay. There we go.
All
Sorry.
right. It's no big deal. It's no big deal. So,
Okay.
all right. Then, so I'm looking at the first problem. I'm thinking, okay, I need to bring my coach buck. There we go. There you are.
Yeah.
Okay, I need to bring my coach bucket notes. I just realized that. But let's see if we No, what were we saying? Yeah.
Oh, what? Oh, I don't quite know exactly. Like, we just did like integration by parts a little bit. Didn't spend a whole lot of time on that though. There's another really weird thing that they started that has to do with like forms and stuff, and I missed the class where she explained it on accident. Yeah. So I'm totally confused. But I think that's what we're doing on the homework. I'm not sure. I sent you with it.
Okay, then so, all right, so integration by parts, and you said something about forms?
Yeah, it's like, I don't know how to describe it because I didn't like hear what it was talking about because I accidentally missed the class, but
yeah.
I don't know. That's what she called it. Oh.
Okay, then.
It's got to do with trig identities, so.
Okay, so it might be the trig substitution. I'm not sure.
That might be what it is.
Okay, then hold on for a second. There is a. 1 second. Oh, shoot. Crap. Okay.
Yeah.
All right, so this first problem here, I've written it down.
Okay, yeah. Okay.
So, okay, what it looks like with all these e to the x, I'm going to try and work this out, and I'm going to see. So, what did you start off with?
What did I start off with?
Yeah.
Don't remember. Let me try to pull up something like that. I think I might have done that one. The section 7 part 2 I haven't done.
Yeah.
Yet. I haven't even gotten to that. I think I did the first one. Let me check.
Okay.
Sorry, Fayetteville has some weird little thing. I did not get that one right at all. Okay.
Okay.
Our homework system's really weird. Yeah, I don't think, yeah, I didn't do that one. Some of them I was able to do, and some of them I ran out of time on. So.
Okay. Let's just see here. Yeah.
How would you approach that problem?
Let me see here. I'm gonna have to remember a lot of this stuff because I don't have my notes with me. I need my notes. But let's see here. Did you try substitution?
I think I did. See, the problem was this is like online homework thing, and ours is weird because if you don't put it in right like 3 times, it locks you out and you got the problem wrong.
Yeah.
But you can go back in later, I think, if you're not locked out, and try to complete it.
Yeah. Let me see here. Let me try it by parts.
Okay. What would you say for you?
Okay, so what I'm doing is I'm trying it by parts now. I'm trying to see, okay, let's see how this goes.
Yeah.
So plus.
Alright, do you do U and GV when you do integration by parts? Is that how you do it?
No, when you're doing integration by parts, or no, I'm sorry, maybe partial fractions, I think is what it is, partial fractions. So I'm really splitting up the bases into a over e to the x plus b over -2 e to the negative x, and then, you know, you sort of cross multiply. Remember that?
Yeah.
Let me get my mouse.
See, the way they showed us everything they said about integration by parts, our ladies just told us to do like the du or u and dv kind of thing. That's kind of how she want us. So I have no idea right there. It's hard.
It's no big deal. Let's just see if we'll just power through this and see what we can do.
How would you start out with a U substitution for that problem? Because I could see where you could do that. Because it's got e to the x on top and bottom.
Yeah, and that's what I was trying to do at first. The only problem is, okay, so let me rewrite this and do that. So, in fact, let me see if I can draw here. So, screen share. Desktop. Start screen share. You can see the thingy. Okay, good. So let's see if I can. Find a drawing thingy.
Okay, I gotta turn my camera off for a second.
Okay.
Because that's about to crash. I gotta move.
Okay, yeah, I understand. Photo booth, FaceTime. Nope. Launchpad, Finder, Applications, Game Center, GIMP, whatever it's called. Oh yeah, I'll use that.
I didn't turn off. Oh well. Okay, there we go.
Okay, so file, new. We're gonna make this as humanly possible. Okay. Oh, I'm sorry.
You fine?
No. Oh, wait, hold on for a second. Hold on. Hello. I'm doing well. I'm helping with some calculus. Yes, ma'am. It's okay. No, ma'am. Oh, yes, we can do. No, you were saying. Oh, I thought you were done. Can you see that? Hold on. Can you see that?
Yeah.
Okay, but yeah. Okay then. Oh, you did. Right. Okay then. So when I wrote this out, what was the integral again?
It's the integral of e to the x over e to the x minus 2 e to the negative dx.
Okay then.
Yeah. I need Code Scott. I had my mom ship all my Cal 1 notes up here because I accidentally left them.
Yeah.
That was a mistake on my part. But, haven't forgotten Cal 1, just Cal 2 is like, what is going on here?
So
Nobody.
how I was going to start it was okay. No, where did I go? How I was going to start it was so you have a over e to the x plus b negative 2 e to the negative x. Cool so far?
Okay.
So now what you do is you cross multiply and say negative 2 e to the negative x a plus e to the x b equals e to the x.
Okay, that's interesting.
So now, okay, so because there's only the e to the x terms, there's only one, so b equals 1. Do you see how I got that?
Yeah.
Because this and this, there's only one e to the x term on both sides. So that means,
Yeah.
so there we go. So now what I can do is say negative 2 e to the negative x a plus e to the x equals e to the x. And I don't know if any of this is correct so far, but I'm going for it. So now what I can do, I'm going to just erase this. Did you get this so far?
Yeah, I got it.
Okay. So now what I can do, go up here, change this back to 1. Come on, come on, come on, come on, come on, come on. Good. Okay, so now negative 2 to e to the negative x a equals, oh Lord, no idea if this is correct. Probably isn't, because then that means a is equal to 0, and that doesn't help me because they're supposed to be opposites. So that doesn't work.
Mm-mm.
Oh boy.
Yeah, Cal 2 is not as easy as I thought it would be.
That's
it's easy.
okay. Yeah. Yeah. You were saying yeah?
Yeah.
Okay.
Do you want to try a different one maybe?
Sure.
We could do section 7.2 because I think that's like what we were on in our class. That's
Okay.
what she said anyway. But the first one is the derivative of, not the derivative, the integral of x sine 2x squared dx. Maybe that'll be a little bit easier to start out with.
Where's it again?
It's the integral of x sine of x, or sine of 2x e to the x.
Okay. Okay, that one shouldn't be too bad. That one, it looks like you're going to have to do, what is it, by parts.
Okay, yeah. That's kind of what we were doing.
Okay.
I don't know what you just did, but I've never used that yet. I mean, we haven't used it yet.
Okay.
My knowledge.
So integration by parts is basically the inverse of the product rule. So what you have is you're picking the integral. So if I'm remembering, u dv is equal to v times u times the
Or minus
minus
of v du.
v du.
That's what they told us.
So what you want, typically, according to Coach Buck, is the value that you choose for u. For u, you want that when you take the derivative to sort of go away. And the value that you choose for dv, you want to be able to recycle it.
Okay.
So for u, the one that we're going to pick is going to be x. dv, going to pick sine of 2x. 2x. So when we take the derivative of u, we just get dx.
Yeah.
We take the integral of v, you know, you could use some u substitution. We'll just call it w just to make it less unclear. dw is equal to 2dx. We divide both sides by 2 to get the dx by itself. So that means this would be sort of like sine of w 1/2 dw integrated would just be 1/2 the sine of, so cosine, the integral of cosine, the derivative of cosine is negative sine, correct?
Yeah. I would say negative cosine.
Negative cosine of 2x is what that whole thing is there. So negative x. So if we apply, so this is what we're focusing on as going to be equal to v from up here.
Yeah.
Negative cosine 2x over 2. So now we just plug it into the formula. So we have v times u, negative x cosine 2x.
Sorry if you hear any loud noises, by the way. The big Razorback football games going on right down the road.
Really? I actually did not know that there was one going on.
It started at 3 o'clock, so
Wow.
yeah. That's if you hear loud noises, that's probably what it is. Or Georgia, one of the two.
Yeah. And so now we do the integral of sine of 2x dx. This is the good thing that we chose u to be x, because now it's just like a regular integral. And the other good thing is that we technically already evaluated it here. So all we have to do is say negative x cosine of 2x over 2, because all of this is going to be over 2 based on the work that we've already done here. We already know that it's going to be over 2 as well. Plus, because we had a negative cosine over here, subtracting that negative cosine, so it's going to be a cosine of 2x. Just so I can make sure that I am being correct. Of cosine. Hold on. There we go. There's cosine of x. Yeah, so okay. So if you take the integral of sine of x, oh wait, no, it's going to be cosine. It's going to be a positive cosine then. So if the derivative, okay, hold on. Oh crap. So there's just some sign errors, nothing major.
Yeah.
So integral cosine. Okay, so integral of cosine of x is sine of x, so not negative sine. So this right here, we put negative sine That's just going to be a positive sign, a positive cosine. So here, it's a positive cosine of x times x, of x times cosine of x, and we could just say minus cosine 2x.
Okay. All right.
There we go. There's that.
Yay! That's one.
All right. And this is good practice because Coach Buck was right. You let it slip and it hits you all again.
Oh yeah. See, I didn't really forget. I still remember a lot of what we did in Cal 1. It's just we started out literally the first integral we did on the first day was a dy, and in Cal 1 he rarely ever did those. He went over them, but not a lot.
Yeah.
And so I'm just like, what's happening here? I don't know what this is. And it just kind of snowballed from there. I'll get tutoring if I have to, because I have to take Cal too. Are you in discrete mathematics right now?
I'm not taking discrete mathematics.
Are you in discrete mathematics right now?
Oh, no, not right now. I'm in physics.
Okay. You didn't have to take a math this year? You're doing comp sci, right?
Yeah.
Okay. See, like, I have to take, I'm in physics too, but I have to take discrete mathematics next semester.
Okay.
And then, like, more math for computers. It's fun.
So, okay then. So now, let's see. What's the next problem?
Alright, it is... Okay. It is the integral of 2x times e to the 3x dx.
Okay, can you repeat that one more time, please?
It is the integral of 2x times times e to the 3x dx.
Okay. So 2x. So one thing that we can do, we can take this out here. X e to the 3x dx. This is another one where it looks like we're going to have to do it by parts, and this is going to be another one that's going to be pretty easy. Again, we pick u to be x because it'll disappear, and then v will be e to the 3x.
Yeah.
That means du is equal to dx, and v is equal to, again, we do some w substitution, I guess you could say. It's going to be, it'll be dw equals 3 of dx, dw over 3 equals dx. So we have e to the w. The integral is going to be e to the w dw, which is equal to e to the 3x over, wait, no, that's wrong. I replaced the wrong thing. One second.
Would it just be e to the 3x?
Not entirely, because it's going to be, I don't think so, not entirely, because you have to factor in for the fact that this this dx that we're replacing for in the integral, technically, when we integrate that e to the 3x, integral of e to the 3x dx, because there's that 3x and not just e to the x, when we do u substitution, there's going to be that 1/3 factor that we have to bring into the picture.
Yeah.
So there's going to be dw, 1/3 dw, replacing that dx over here. So what ends up happening is we get e to the w over 3, which is just e to the 3x over 3. That's why it's not just e to the 3x. So we have e to the 3x over 3.
I don't think my cow professor is actually done stats, so.
So now what we do is we just continue to integrate. So u times v is just
So 2x e to the 3x over 3 minus the integral of e to the 3x over 3 times 2? No. Yeah. Times 2 dx, right?
times 2 dx where?
For the integral.
Yeah, that's right, because you have to keep that 2 in there. So yes. Thank you.
Okay.
There we go.
Okay. All right.
And then you also have to include the constant of integration, of course. There we go. It's all coming back to me now.
I really wish I could have taken this when I was in high school. This would have saved my butt this year. You know, if I don't do good this semester, I can come back during the summer and take it at Euler, and it won't affect my GPA. My goal is not to fail this class.
Yeah, that's a good goal to have.
Yeah. I'll get this. I'll get it. Good thing about it, though, is that my teacher, she doesn't care too much about when you turn stuff in, as long as it's done right.
Yeah.
So this was due last night, and she told me yesterday, it's due, but you can do it. If you need to take an extra day and do it, that's fine. It's not going to count against you as long as you get it right.
Yeah.
But see, we're still having problems with it. I can't even get on to see the actual problem right now.
Oh,
jeez, my you are. I think it's probably just because there's so many people accessing it and stuff. I mean, not right now, because everyone's at the football stadium, but it's just we've been having technical issues with some of our stuff.
Oh, I see.
Yeah, it's not always the best,
Huh.
but it's okay. I'd rather do it on paper, but that's just me.
Yeah, I get that. Okay, then. So now let's see. Which other one do you want to do?
Let's do one with a. Okay, let's do this one. It's the 2x times sine of x times cosine of x dx, the integral.
Okay, then. Okay, that one shouldn't be too bad either.
Yeah, that one didn't look too bad. That's why these are the easier looking ones, surprisingly. I guess she gave us easy ones for our homework.
Yeah.
I wonder if I can.
Yeah.
Oh no, they're the hard ones. I found them. Oh, she wants.
So what we can do here is, to me, what it seems like, again, u is going to be x, and then dv is going to be all of this.
Okay.
So now, take the derivative, du equals dx, and v, so we're going to integrate this, sine of x, cosine of x. So again, we're just going to use w for the sake of clarity. W equals sine of x. dw equals cosine of x. So therefore, what we're doing is we're finding the integral of w dw. Now it's just power rules. So u squared over 2, which is just equal to sine squared x over 2.
Yeah.
So now that we have what v is equal to, we can just begin to integrate. So go back over here.
Hold on just a second. Or
Okay.
it's sine squared over 2. Okay. Sorry, I didn't see that last part.
Wait, what now? Oh, sine squared over 2. Yeah.
Yeah, I was like, that was the part that I missed. Okay, alright, okay, yeah, I got that.
Okay. Racing. And so now I'm going to go to u times v, which is just sine squared of x over 2x minus the integral of sine squared x over 2 dx. So we can still...
Oh, hey, would it be times 2 in that interval?
Yes, it would. All of that. So I forgot. I forgot to include that or do that here. So yeah, all of this is times 2.
Okay.
So
we can pull that out. Okay.
So what this allows us to do is we can just say that this is sine squared x times x minus the integral of sine squared x dx.
Oh yeah, I see.
Yep. So now erase that here. So now it's so the integral of sine squared. Oh Lord, what is sine squared? It would be so okay. So we have to say mu is equal to sine of x. I feel like I'm overcomplicating this, but we'll see. No, that's not it. Because then you get us cosine.
Yeah.
So let's see here. You just apply power rule? No.
Is there an identity for sine squared?
There should be.
Yeah. Oh, there is. Oh, crap.
One might. Is it like a? Oh crap.
Let me look. I forgot. She gave me a thing that had it on there, and of course, I don't have my thing here. Let me see if it's online. Right.
Okay.
I'm looking at the course document. Trig substitution solutions, trig intervals. Let me look at this right quick. She gave us a worksheet.
Okay.
No, that's not it. Do this. Trig substitution solution. No, but that's kind of what I was doing with the other thing. Let me see.
Could you look online for identities, or would that be considered cheating?
I can look online.
Okay.
No, it's not cheating unless you blatantly copy somebody else's work.
Okay.
But like looking up like things to help you is not cheating. I wouldn't think so. Like I think she wants us to do this.
Here we go. Let's see here. Oh. Wait, no.
Is it? Oh, it's 1 minus cosine.
Yeah, that's what I put. Yeah, that's what I put down. 1 minus cosine squared.
Yeah, that's okay. Yeah, I'm sorry. I left the sheet that had that in my room.
So let's see here. Oh Lord. Let's see. Wait. So if oh my goodness, I should know this.
I think it's one. Is it 1 minus cosine squared?
It is
That's what sine squared is. Okay.
because that's Pythagorean theorem.
Yeah.
Okay, then so sine squared. Coach Buchan. Oh my gosh,
Coach Buck, save us, please.
I can see his face now, saying, "Are you feel challenged?" But
Oh, my little brother's in his class right now. And, yeah, he's in AB this year, and he made his first C on a test, and I'm like, just you wait. You have no idea how many tests you're probably going to fail before you finish this class.
okay, then let's see here. Okay, thinking through this. Sine squared of x. So do the integral of sine squared of x. What do you take the derivative of and get sine squared?
Would you just take the derivative of x?
No. Wait, I think I was overcomplicating it. So if you take that, 3 cosine.
Wait, let me go back.
Okay.
Back. 'Cause I found a thing where it was pretty similar.
Okay.
Okay, yeah, they changed. Alright, let me do this. Alright, so let u equal x, du is equal to dx. Alright, we're good there. So, sine squared, it would be, our integral would be sine squared of u. Sine squared of u du. Okay, so then what we would go from there is it would change into 1 minus cosine of u. I think. Yeah. Yeah? Yeah.
Wait,
Minus cosine of u. Du.
1 minus
then,
cosine of u?
Yeah. Since we let u equal x.
Okay, let me see here.
That's what I did. 1 minus, would it be 1 minus cosine squared of u?
Right, that's what I'm saying. And plus, changing it to x doesn't change the problem. You just used a different variable.
Alright.
But let's see. Let me.
What is the integral of cosine of u? Or cosine squared of u? Wait.
Yeah, that's what I'm.
Or.
Shut the bird up.
Ah.
Shut the bird.
Please. Let's see. 1 second.
Okay, so.
Cosine of x. I think. Trig identities. There we go. God bless trig identities. I found the blessed trig identities. Let's see.
Oh, okay. I see what they did. It's this half angle formula.
Huh?
This half angle formula. So sine. So how about trig identities? So okay, sines.
It says 1/2 of 1 times, or it's 1/2 times 1 minus cosine 2x.
Yeah, that's an identity. That's the half angle. That's a half angle formula. I just looked. So okay with that. So okay, so that makes a little bit more sense. So just things up. So sine squared of x x minus of x times x minus 1/2 the integral of 1 minus cosine of 2u, then or 2x I should say, 2x, and then we'll say u is equal to 2x. So that's what I'll go off so far, 2x. And then du is equal to 2 dx. Okay, so now what they did, okay, now I see what they did. What they did was you split this up into 1/2 x. Okay, you put this, okay, let me make this a bit clearer so I can explain this a little bit better. So now what you do is, because you still can't really take the integral of this so far, it seems like what they did was, you might have already come to this conclusion, is that they split the integral up even further to 1/2 times the integral of basically dx times 1, or just dx, minus the integral, okay, cosine, and because we've already done the substitution, we just say u, and then 1/2 du. Then we can take the integral of this relatively easily, put this right here. So sine squared of x times x minus x over 2. Okay, this is all subtraction, so I need to preserve my signs. So 1/2 x minus so the integral, so minus the integral, so sine of, because this is u is equal to 2x, I'll just substitute it right away. Sine of 2x over 2. Is that looking right? Is that looking right so far?
Yeah.
Okay.
Shut up.
Hey. Sorry, you're like half asleep right now.
Okay, so just to make sure, yeah, the integral of cosine, because the derivative of sine, yeah. Okay. So
what bird is that?
I don't know. Over the chat thing. Oh my god.
So now we have this as the integral sine squared of x times x minus x over 2 plus sine of 2x, that is sine or sin,
Okay.
of 2, plus c. This is solidly written. But you got it?
Yeah. Yeah.
Okay.
I think I have time for like one more.
Okay.
If you want to do that.
Sure.
What do you mean you got time for one? You're not doing anything today, you lazy college student.
Have to give me up with your
Is that Giorgio?
Yes, that is Giorgio.
Giorgio.
I took a nap. I just woke up. I heard some squeaky noise. I thought you was watching a bird video.
Yeah, I definitely was watching a bird video.
That's your fault, Giorgio.
Oh, wait, essays, Leon.
He's in a bunch of classes because he's got a.
Because I'm a doctor, don't worry about it.
You're a doctor and you learn how to write essays.
Okay.
Alright. Want to do one more?
Sure, no problem.
Okay. We may have to do this again sometime.
Oh yeah, no problem.
No, we'll hang out with you.
Yeah, well, and maybe next time we'll be there in person.
Okay.
Yeah, it's not that far of a drive. Yeah. Looks like Simran and everyone else is down there. All of our friends went to...
How's the college life treat you, Chris?
It's been awesome. The classes are easy so far.
Nice.
Granted, we've just started, but still.
Yeah. Oh, when did you guys start?
The 17th, or I think 17th.
17?
Yeah.
We started, I don't know, like the 22nd. We've been going, this is like our 3rd week.
Wow. Yeah, same here. Same.
Okay. Let me pull out this one more time. Maybe discrete mathematics will be a little bit better than this.
But this gives me something to practice with, so thank you. This worksheet.
There you go. No problem. You're welcome to use it. If you want more, I have more.
Thank you.
She had to post them on. She had to post them online because we couldn't do it from the thing. Because the thing is messed up. Like I can't get on to do half of the problem. All right. Let's do. Oh boy. Do you want to do a definite one?
Sure.
Okay. I think we actually did this the other day because I had to take an extra class for almost all of my classes because I'm in some college of engineering up here. And so I have to take an extra math drill class for this stuff.
Oh.
So fun. Okay. So the integral is from 1 to e, and it's the natural log of 2x dx.
Okay. This one shouldn't be too bad either. So let's see here. So repeat that one more time, please.
It is the integral from 1 to e, and it's the natural log of 2x dx.
Okay. Okay. 1 to e natural log of 2x dx. So first and foremost, we have to say u equal to 2x du
Equal to 2 dx.
Yep.
And 1/2 u is equal to dx.
And so then we change the boundaries as well.
Yeah. So it's from 2 to 2e.
Yep. 2 to e.
Oh, u. See, something that bothers me though is my teacher when we do natural log, she always says log, so I write it out as like a log.
Yeah.
And it's a natural log, and you're like, those are very different things.
Yeah.
Very different things indeed. Alright, times 1/2 du. We can move the 1/2 to the outside.
Yes. And so now what we do is we change u to be natural log of u. Then du, or dv, I'm sorry, would be du.
Oh.
du, not to be confused. You know what? This is getting confusing, so I'm going to use so I'm going to be using different variables for this integration by parts. So we're, instead of u and v's, we're going to say w and z. So w is equal to natural log of u. dz is equal to du. dw would be 1 over u. And then z would be equal to just u. So now, just applying the same principles, we have 1/2 times the natural log of u times u plus or minus the integral of du over u. That's just natural log again. But, okay, we have to incorporate the boundaries that we set up earlier. That's just the only difference. So,
Okay.
So we incorporate these boundaries of 2 and 2e. So we have 1/2 natural log of u times u minus the natural log of u. And again, from 2 to 2e. So now all we do is we replace all of the places where there is an e, where there's a u with a 2e, and set, that.
Yeah. Yeah.
So 1 natural log of 2e minus natural log of 2e. Oh, wait, no. I'm sorry. I skipped a step. Natural log of 2e times 2e.
2e.
Times 2e minus natural log of 2e minus the natural log of 2 times 2 minus of 2 minus the natural log of 2. So we have that whole, that whole expression. So now what we have is the natural log of 2e would be, what power of e is this? Wait, hold on a second. Log rules. So, okay, I'm trying to remember my log rules, so it's okay. Log rules. Okay, 9 more rows, so 2 to the 4, so see here. Okay, so what it ends up being is this, that multiplication, we can just split it up into additions. So we have 1/2 the natural log of 2 plus 1 all times 2e minus the natural log of 2 plus 1. Again, putting that in parentheses. Do you see where you are following me so far?
Yeah.
Okay. So now we do the same thing on the other side. Right here. Sort of, not really. We can just keep this as it is because there's no e's on that side of the equation. But we will distribute the negative. So that will be natural log of 4. Okay. Minus or plus rather, natural log of 2. Going down, we have 1/2 the natural log of 2 times 2, times 2e plus 2e minus the natural log of 2 minus 1 minus natural log of 4 plus the natural log of 2. So then you can sort of distribute this half out. Natural log of 2 to the e plus e minus the natural log of 2 over 2 minus 1/2 minus the natural log of 2, because again, when you're multiplying by that 1/2, it's the same as raising this inside to the power of 1/2, so that would just be 2, plus the natural log of 2 over 2.
Okay, yeah.
And so these two cancel out,
Yeah.
leaving us with, I'm going to erase this top part, okay?
Yeah, that's fine.
Okay, leaving us with, so we have the natural log of 2e plus e minus 1/2 minus the natural log of 2. Something like that. Now again, you might have to double check this to see if all of this is actually correct, but I hope it is,
Okay.
because all of these would just sort of, yeah, oh,
Yeah.
yeah. I'm not entirely sure, but I hope it's correct.
Okay. Thanks for working it out with me.
No problem. No problem at all.
Were you? What?
Hmm?
Oh, sorry, Giorgio said something. Yeah.
All
Very helpful.
Good. All right then.
Yeah.
Okay.
Yeah.
All right then. So this will be on the public forum. Hopefully, this will accumulate. So I'll try and put some notes of what we covered in this, just for other people's benefit. So all right.
Okay.
Okay. I will talk to you later, Julia.
See ya.
See ya.
Bye, Chris.
Bye, Giorgio.
Bye.
Bye.